Have you ever just stopped and thought about how incredible it is that we can move? I mean, really think about it. How we can walk or run or just throw a ball with such amazing precision. Well, today we're going to pull back the curtain and unlock the science behind it all. All right, let's jump right in. Just look at this. Whether you're a world-class athlete making a powerful leap or, just jogging through the park, your body is this unbelievable piece of engineering. So where do we even start to understand the physics that makes all of this happen?
Well, the answer is in this super fascinating field that actually builds a bridge between biology and physics. It gives us a totally new way to look at how we move.
And that field is called biomechanics. It's pretty much what it sounds like. You take biology, you meet mechanics. It's where we take all those principles from your old physics class, things like force, velocity, all that stuff, and we apply them to understand how living things, especially us, get around. You could almost call it the engineering of the human body.
Now, you've probably also heard the term kinesiology, right? So think of kinesiology as the big, giant umbrella for the whole study of human movement. Biomechanics? Well, that's a super specialized field right underneath that umbrella. It gets into the real nitty-gritty, using the tools of mechanics to put numbers to our motion. It's all about quantifying how we move, not just saying that we do.
So, how do we actually start thinking like a biomechanist? Well, it really all boils down to two key ways of looking at things. First, describing what's happening, and second, explaining why it's happening. So come on, let's open up the toolbox and see what's inside. Okay, so here's our game plan. We're going to dive into these two main branches you see here, kinematics and kinetics. And trust me, by the end of this, you're going to see movement in a completely different light.
And this right here, this is the most important thing to get. If kinematics is the play-by-play announcer just telling you what happened in the game, then kinetics is the expert color commentator explaining why it happened. It's the difference between just seeing the action and really understanding the invisible forces behind it.
All right, let's start with kinematics. This is the what of motion. Think of it as the geometry of movement. It asks really simple questions like, how far did it go? How high? How fast? So for a high jumper, kinematics is just describing their position, their velocity, their acceleration. It's the pure, raw description of their trip over that bar.
But then we have kinetics, the why. This is where it gets really interesting because it's all about the forces that create the motion. So for that same high jumper, kinetics isn't about how high they went. It's about the massive force they pushed into the ground to launch themselves, or the turning forces, the torques in their joints that propelled them up and over.
Okay, so to talk about all this stuff, whether it's kinematics or kinetics, we need to be on the same page. We need a shared vocabulary, a common language, so we can describe exactly where things are on the body with total precision. And to do that, we use these directional terms. You can think of them as our body's own internal GPS. Let's do a real quick lightning round of a few key pairs so you can start speaking the lingo right now. First up, medial and lateral. It's super simple. Medial means it's closer to the center line of your body. Lateral means it's farther away. So your nose is medial to your ears. See? Easy enough. Next, we've got proximal and distal. This is all about how close something is to where a limb attaches to your trunk. So your elbow is proximal to your wrist because it's closer to your shoulder, and your ankle is distal to your knee because it's farther away from your hip.
And finally, anterior and posterior. Anterior is just a fancy word for the front. Posterior is a fancy word for the back. So your kneecap is on the anterior side of your leg, and your shoulder blades are on the posterior side of your body. And just like that, you're speaking anatomy.
Okay, so we've got our new vocabulary down. Now, here's the fun part. Let's actually use this language to describe some of the basic, fundamental ways our joints can move. Let's start with two of the most common movements you'll ever see, flexion and extension. The perfect example is a bicep curl. When you lift that weight up towards your shoulder, you're decreasing the angle at your elbow. That's flexion. And when you lower it back down, you're increasing the angle. That's extension. Basically, flexion bends a joint and extension straightens it. Simple as that. And how about these two, abduction and adduction? When you lift your arms straight out to the side, you're moving it away from your body's midline. That's abduction. And when you bring it back down, you are adding it back to your body. So that's adduction. That's a great little mental trick to remember it, right? So look at that. In just a few minutes, we've basically built a powerful new toolkit that lets you see and understand human movement in a way you probably never have before. And if you walk away with just one thing today, please let it be this.
Kinematics describes what happened, kinetics explains why it happened. That one little distinction, it is the absolute key to unlocking a much, much deeper way of seeing how we move. It's the difference between just watching and truly seeing.
So you've got it now. You have the tools to describe movement with real precision, and you have the framework to start asking the right questions. You can look at literally any movement and ask yourself, am I looking at the what or am I looking at the why?
So here's a little challenge for you. Next time you're out for a walk, or you're lifting something at the gym, or even just watching an athlete on TV, don't just see the movement, try to analyze it. With this new toolkit, what new details are you going to notice? What new questions are going to pop into your head? Thanks for geeking out with me on the incredible science of movement.